Food waste and foodborne illness come from the same invisible problem, is uncertainty. Consumers cannot see what is happening inside sealing packaging. The United Nations Environment Programme report in 2024 and 2025 that over 1 billion tons of food are wasted every year, much of it discarded out of the not conferred spoilage. Meanwhile, the World Health Organization reports hundreds of millions of foodborne illnesses annually. The failure lies in how we measure freshness. Expiration dates track time, not biology. Storage conditions fluctuate, temperature change, microbial activity evolves, yet the label stays static. So we either throw away safe food or consume food that is already unsafe. If the problem is invisibility, the solution must be visibility. SPORE, spoilage recognition, turns microbial activity into clear visual signal directly on packaging. It operates through three integrated scientific layers. The first layer applies metabolic fingerprinting. When food spoils, microorganisms release specific chemical byproducts such as organic acid, volatile amines, and sulfur compounds. Spores embed chemically selective indicators in a thin polymer film inside the package. As this metabolism accumulates in the heat bed, the indicator reaches and forms a discrete color pattern. Instead of a simple fresh or spoiled label, consumers see a gradual visual shift that reflects the actual spoiled pathway. But freshness is not only about the present, it is also about what happened before purchase. The second layer introduces chemical memory through time temperature integration. Slow reaction compounds change color irreversible, accelerating under heat exposure or cool came description. Stable storage produces minimal change. Mishandling leaves a visible trace. Two identical products can therefore reveal different storage histories. SPORE does not just detect spoilage, it records. The third layer ensures instant understanding. Responsive optical film amplifies subtle chemical reaction into strong visual contrast or transparency safe. Human process pattern faster than data. Clean and uniform means safe. Structural transformation signal biological risk. No devices, no interpretation, just visibility. Together, these three layers convert microbial metabolism into actionable decisions. SPORE begins where uncertainty causes the greatest loss. High-risk perishables such as meat, seafood, dairy, and ready-to-eat meals. From there, it expects to could change logistic and retail quality control, where handling history determines safety with the same scientific foundation it later expects to infect nutrition, functional food, and bioactive packaging like cosmetics. It also addresses three tiers of biological risk awareness. First, producers and retailers facing hidden spoilage losses. SPORE provides early intervention signal. Second, consumer and manufacturers who rely on static data or sensory judgment. SPORE clarifies real biological status. Third, high sensitivity markets where spoilage is invisible and risk tolerance is minimal. SPORE refers what refers nothing else. Strategically, SPORE does not compete as a cheaper label, it competes as a smarter system. Expiration date measure time. Basic indicators detect single chemical shift. SPORE tracks real microbial metabolism, adapt to storage conditions, record temperature exposure, and communicate safety visually. It shifts packaging from passive estimation to biological intelligence. Our launch began with controlled pilot in measurable, high-risk categories. After validating performance, we moved into limited retail development to demonstrate reduces waste and increase trust. With proven accuracy, we enter sensitive market and scale globally through manufacturing partnership and licensing. Food safety should not depend on guesswork. Food waste should not be driven by dupe. SPORE makes freshness visible, history traceable, and safety intuitive. It is not an incremental upgrade, it is a redefinition of how packaging understanding food. SPORE spoilage recognition.